Hi there, and welcome to the second lesson in this intermediate JavaScript tutorial series. This is likely going to be the first of two episodes that we use to talk about functions. We'll be talking about the differences between normal functions and arrow functions, as well as some of the implications of those. And at the end, we'll run a speed test. If you find any of the information in this video useful, feel free to drop a like or subscribe to get more content like this. Let's get to it. As always, all the content that we cover in this video will be found on GitHub, link in the description. This time around, we'll be looking at functions in this functions v arrow functions.html. You can just open that up in any browser and open up the console, and that's pretty much all you should need. Now, just as a refresher, I've got examples of a standard function followed by two different versions of the arrow function. We have function, name, the arguments, and you can either do things or return a value. In an arrow function, however, the main difference is that you don't have a name. It's an anonymous function. So you're starting with the arguments, followed by that arrow, which is an equal sign and an is greater than symbol, and then you've got your statements. Now, you can also do implicit returns in arrow functions by simply not including the curly brackets, or you can use parentheses. In some case, that's what you'll require. For example, if I wanted to create one that returns an object, because of the curly brackets, you're going to need to use parentheses. So you could say something like that. Let's look at the main differences between these functions. It pretty much all centers around the fact that arrow functions are anonymous, so they have no self-awareness. They can't reference the this keyword, the arguments keyword, and they cannot call themselves because they have nothing to look at. The first example of this is this object function test. I'm defining a constant object with an attribute of 0 and a method test that simply increments that attribute by 1 and returns the value. So we're going to start by logging this object attribute, which will be 0, increment it a few times, and we can see that here. If we run object function test, as expected, the initial value is 0 of that attribute, and then it jumps up each time, 1, 2, 3. Now, with arrow functions, that's not going to work. We're defining that same object. This time, I'm including a isShown, which allows you to pass in a true Boolean value if you want to actually log what this is, and that's for debugging purposes essentially when it fails. So if we run object arrow test, you'll see we can actually access the attribute 0, but whenever we try and change it, we're getting this not a number, which you might think is a little strange, but there's actually a good reason for it. And when we run it with that true value as the argument, we're seeing that this is actually referencing the window, not the object. Now, why is this value not a number? Well, what we're essentially doing is saying return window.attribute, incrementing it. That would be the equivalent of saying ++ undefined, which equals not a number. So, for example, if we wanted to say window.attribute is set to 0, we could then run this object arrow test and get 1, 2, 3. It just wouldn't be a good idea, especially given that you already have attribute in that object. You're referring to two completely different variables, both named attribute. As for arguments, that's a keyword that gives you access to the arguments of a given function. So in the case of print arguments as a function, if we run it without any arguments, you'll see this arguments object with a length of 0. But what we can do here is say string for the first argument, 0 for the second argument, and even an object for the third argument, and we have access to all of those. And that can be very useful for some complex functions where you want to react differently based on the number of arguments or the types of those arguments, and you don't always know how many there are going to be, or you want to be able to pass in a bunch and you don't need to predefine those. However, if we try doing the same thing with our arrow functions, arguments is not defined. You just don't have that ability when it comes to arrow functions. Now, what are some of the main implications of these differences? Well, as we saw, arrow functions cannot be used as methods, as in functions for objects. And we saw a pretty clear example of that. They also can't be used for event handlers if you want to be able to remove them. Now, if you haven't worked with event handlers recently or ever, let's take a look at what I mean by that. Well, here I'm grabbing on to those 3 buttons based on their element ID, and then creating this function log a click. And what that's doing is it's saying if this.I exists for log a click, then keep it the same. But if it doesn't, make it 0. And then we're incrementing it by 1 and logging out clicks logged. Now we can add that event listener to button 1 by simply saying add event listener for a click and then pass it the function that we want to connect. And then we're doing a similar thing on B where we're actually just saying add an event listener so that when it's clicked, button 1.remove event listener, and you're removing that same function. So what does that mean? Well, if I click counter using function, we're going to see that it logs out the value 1, 2, 3, etc. And you can do that as many times as you want. Not only does the function have access to this, but it's now been connected to that button. If we click to remove the event handler and we click the counter again, it's been disconnected. A little challenge is then maybe you could create another button here which reconnects it to that same function. And in that case, you can actually pick up right where you left off, so to 8 to 9 to 10, etc. Now, what we've done with the third is just point out the fact that this is still referring to the window when we're trying this event listener. So if we click on that, you can't track I within the scope of that function. You also can't remove it because once it's a part of it, you have no reference to it. So at this point, things aren't looking too good for the arrow functions, but as you might expect, there are a lot of workarounds that actually make them extremely powerful and useful in a lot of instances. The first being that you can actually reference arrow functions with variables, meaning you can now use them for event handlers, and it can call itself, which is different than this, giving you the ability to create something like a recursive function. So if we look at the first code example, we've got this little type here, input, A, B, C, and each time arrow input has changed, instead of the value this, event.target is going to give you access to that input. Whereas before you could just say this.value, arrow functions allow you to still access it via that target attribute. So if we look at the code here, arrow input change event, and we just have event.target.value that we're logging out. It is then added on the key up to on arrow input change. We also created this function remove arrow input listener. The use of this underscore is something that you'll see sometimes where it essentially saves you from having to use parentheses. A lot of times the underscore may be used as an argument that is intended not to be used, and so I just wanted to throw that in there so it's something that you can see. You may become a little bit familiar with it. Anyways, all that this function is doing is removing that event listener, referencing the on arrow input change. If we run that with remove arrow input listener and then continue typing in here, nothing, which is what we would expect and hope for. And finally, we have this arrow factorial, which is an example of a recursive function where we're saying if x is greater than 0, return its value plus the factorial of x minus 1. So you're calling yourself. If you're 0, just return 0. And if we run that on 1, we'd get 1. 2 would be 3, 3, 6, 4, 10, and so on. One thing I want to mention is that it's really important to just define that as a constant so that you always are keeping that reference the same. You don't want to reference it another way and change the name. It would just lead to headaches. I'm going to clear this off and we can look at the speed now. So it used to be the case that the traditional JavaScript function was faster than the arrow function, and the implicit function was even slower than the explicit. But with modern optimizations in browsers, that difference has basically diminished. And to prove that, I wrote this run function test. Essentially what we're doing here is creating a test function that takes in a value and a function. It counts up to that value and it multiplies where you're at by the end value each time. So if you say 10, it's going to say 0 times 10. Then it's going to run it again, 1 times 10, 2 times 10, 3 times 10. After running through all of those, it'll tell you how long that took. So what I'm doing here down below is writing the same function 3 times. Our function, our explicit arrow function, return time a times b, and our implicit, where we're not including a return statement, just our values. Then run function test is going to run the same test on all 3 functions and log the time for each so we can compare. So just as an example, if we run it on 10, we're going to see it's ridiculously fast, obviously. It's worth keeping in mind these are milliseconds, which is 1,000 in 1 second, and you're looking at 3/100ths of a millisecond. So ridiculously quick. We can run this again, and you'll find it's not the same each time exactly. It has to do with whatever processes are also running on your computer and what the browser is doing. And if we amp this number up a bit, you start getting slower and slower calculations. At this point, it's something like, what is this? 10 million. I mean, we can run it 100 million as our x value, where we're multiplying 0 times 100 million, 1 times 100 million, 2 times 100 million, all the way up to 100 million for all 3. And each is taking less than a second. So if you're concerned about performance, you should probably look towards your design patterns within your application and not be too concerned about whether you're using functions or arrow functions, because you're going to get pretty much the same performance regardless. So what are the main takeaways of this? Well, a few things. Obviously, if you're needing to run methods within your object, you're going to need to use functions. But apart from that, what it really boils down to is consistency. If you're on a team, you want to define your conventions right off the bat so that everyone's doing the same thing, because code readability is going to be more important than trying to get performance or anything out of the functions. It's obviously important to know when you have to use functions, when you can get away with arrow functions, and understanding especially what they look like, because sometimes the arrow functions might trip people up if they don't include the parentheses around the arguments, or they don't include the parentheses, or they'll use curly brackets or not curly brackets. So it's good to get familiar with all the different types that you might see, but in the end, again, it's about consistency in your code and making things readable, not just short. So that's all for today. I hope you got something useful out of the video. Again, feel free to like, comment, subscribe to support the channel, and I hope you have a good day. Thanks.